I'm Mike Schwartz. I'm with CalLab Solutions. We're the one that put together the Metrology.net platform, and we're continually looking at ways to build better metrology software. Metrology.net, we built it as a systems of systems design, so it can come in and do a lot of different things. This Metrology.net Lunch and Learn, I want to focus it on what we did building drivers with a tool that we're calling Reusable. So, and it's a DLL that will get, you guys will get the source code. So people that are working with Metrology.net, you'll get the source code for this so you can step through it and see how it works, and it'll actually help you minimize the amount of code it takes to write to do a lot of common calibration things. So I always like to talk about learning objectives. This system here is a common object-oriented programming language, and there's a lot of things that you can do with object-oriented programming languages that make things a lot simpler, and you get a lot of reuse out of code. So that's one of the things, inheritance and object-oriented programming, that's really powerful. We're going to talk a little bit about the new Reusable DLL and how you use it. And then we'll talk about some .NET reflection, which is what allows you to do a lot of very dynamic things with programming languages and with the .NET infrastructure. Cover how the properties and attributes work, and a new attribute that we added into the Metrology.net DLL that will automatically push runtime configurations out, so you don't have to. When you're using Reusable, all you have to do is put the attribute, and it'll become something that's runtime configurable for you. So we'll also hit in here and cover testing and running Metrology.net a little bit, so you can see what's going on in there. So everybody here knows who CalLab Solutions is, so I'll just breeze past this and jump right back down into the problem statement. So one of the things you guys will hear me say a lot is every line of code you write is a line of code you have to debug and support. So we get a lot of problems inside of the metrology software world when we're working with these scripting languages and things, that we keep building more and more and more code, and we've got to go back and support and maintain that code. So anytime we can reduce the amount of code we have to support and maintain, it's very good to hit the efficiencies of automation. So as much as 80% of the cost of software is back into the support and maintenance. So if we do something that takes us, say, an hour to write that piece of code, we have to expect that on the back end of that, there's going to be another 4 hours on the back end of that of support and maintenance that goes into that 1 hour of code that we write. So our real enemy is to write less code, so we have less that we have to support and maintain, and hit that 80% or minimize that 80%. So the problem that I came across here is I needed to make some changes in my drivers. I wanted to add a feature into my drivers that I didn't write the first time in, and I had to go back in and make these changes. So I wanted to do it in such a way that I wasn't copying and pasting the code, because every time you copy and paste your code and make a change to it, a lot of that code that you copied and pasted is code that you're going to have to debug and support down the road. So we want to minimize how much we copy and paste, and we want to start reusing a lot of our code. So we want to make it something we can call as opposed to cut and paste. So the problem that I had is when I first wrote all of my drivers for capacitance and current and resistance and voltage, I wrote all of my drivers to take the values right out of the calibrator, okay? And the problem is sometimes when we're doing more accurate voltmeters, the calibrator can't put out the short and the open with the accuracy we need to pass the device under test. So we needed to put in an option there that instead of using the 55 or 5700s output for 0 volts, that we could prompt the operator to connect a short do that measurement with a short, then move on and use the calibrator for the rest of that. So that was the problem. And if you do the math on here, is if each one of these has 3 drivers and I've got three calibrators I need to do that on, that comes out to 9 pieces of code I have to write. But the transmill calibrator has 2 currents and 2 capacitance and 2 resistance. And the 5500s have capacitance resistance. So I was looking at about 12 drivers I had to go back in and update with this feature. And each one of those drivers had a little bit different of how they implemented things. So I wanted to come back in and come up with a slicker way to do this. And in doing so, I also said that I wanted to make the configuration, the runtime configurations of these, of prompting the operator when he's running the calibration. Does he want to use a short or an open, or does he want to use the calibrator? So I had to make the code changes, and I had to prompt the operator for him to make those changes. So I decided that I was going to basically write everything down into a reusable set of classes. So I created a reusable test process, typical source, test process, typical measure. And the idea behind this is how I source volts DC out of a multifunction calibrator is pretty much the same process. The only difference is going to be how I handle my connection messaging and how I iterate through my processes based on those connection messages. So I started sitting back and whiteboarding and abstracting these things out, and I came up with an interesting concept. So what's going to happen is in the old code, we're going to call our 5500 source volts DC, and we're going to go in there and write that. Do we want to use a short or not a short? And we're going to have to go in there and write about another 200 lines of code. And that 200 lines of code is going to make the driver about 500 lines of code. And if we do that across all of our code, we're going to add about 2,400 lines of code that we have to come back in and build and then debug and support. So we didn't want to go in and do that. So as we started whiteboarding this stuff out, we wanted to look at these high-level changes that we were going to put together. So in these high-level changes, we started looking at how the calibration process works abstractly. And what we discovered is we need to be able to take the connection message, and with the connection message, add to that connection message the data points that we want to test inside of that connection message. And this is typically, if we're going to write a metcal procedure and start jumping around in the metcal procedure, that's in a sense what we're doing is we're saying in this connection, let's do these data points. So we put the data points in a group and attach it. But in an object-oriented programming language, we can actually build a connection object that can have a set of data points attached to it. So how we did that, if you look at the over here on the left or over here on the right, if you look at how we run our typical calibration, we're going to start a calibration. We're going to take all of our data points. We're going to check, are we in our connection? If not, make a connection. Then we're going to run the calibration. Once we get through all of those data points, we're going to check, are we still in the connection? Give a connection and continue to iterate through this. So that would be how we do it in a typical calibration. And as we pulled this apart, we said that each of our connections, we can make that connection. And then for each of the data points that's in that connection, we can run the calibration. So in a sense, we can move that connection out one layer. And as we move it out one layer, that allows us to get very efficient in how we can write our code. Here, this is the first look at how we're going to use the reusable. And you guys know from my previous slides how these light green areas are showing 80% of our code is already written. And we just got to come in and write the specific test processes. Well, now if we create a reusable DLL, we can shrink that amount of specific code we have to write as much as 1/3. So looking at the overall code that we're going to have, we're typically going to call our test process subbase. Okay, so we're going to put that in our reusable code. And then we're going to have our source, which is going to be our message linker, or our UUT, which is going to be our UUT driver. We're going to have to come in and do our runtime test setup so we can make that a reusable piece of code. And then for each of our runs that we're going to run, we're going to create a runtime connection sequence, which is a dictionary of our connection states. Then we're going to have a pre-run, a pre-loop, a run, a post-loop, and a post-run function calls. And the run function is what we had to write, which is typically our green code. But in this case, we're going to make our run function generic. And as we make our run function generic, we can use anything that's a source and tie that in to where we can pull that in and run it. So it's going to drastically shrink the amount of code that we have to write. As we come in and grab this, so if you notice right here, we were inheriting from test process, and now we've got this cool tool called test process typical source. So now in the way we can write the driver with the third less code, we're going to add to it the reusable code. So we're going to bring up our reusable code and make that a tool that we can add. As we add in our reusable code, we're still going to have to create all of our creation code is going to be the same. All of our header information is going to be the same. All of our properties are going to be the same. And all of our equipment is going to be the same. What we're going to change is we're going to add to it properties, and we're going to add to it our runtime operations, and our filters are going to change slightly. So that's typically how we're going to come in and run this. We're going to have an overwritable function that's pre-run that's just going to run a true. So if we don't have any pre-run operations we need to do in our connections or in our running our processes, if we have zero work that we need to do there, we don't have to override it. It will call this function in its place and just return true. Same thing with preloop. We have no operations we want to run in the preloop. We just leave that preloop. So these overridables in object-oriented programming, we can actually call them to where they override that sub-function in there. So we don't have to write a superclass that has those function calls. We can just keep it very basic. So now when we get down into our run function, that's our generic run function, we've added to it a call of our pre-run, and we've added a call to our pre-loop. Okay? So before we go reset up any equipment, before we go run any configurations, we're going to make this call out to a pre-run. If we're not having any special operations there, it's just going to return true, do nothing, and keep running. If we have operations in there, then it's going to perform those operations and return true. So we've added two calls in our generic loop of how we typically looked at our code. And then you can see here, so for each one of our keys and our connection sequences, we're going to set our connection state with what we put in our connections. Then we're going to go down and filter out our test point loops so that we get out of our connection, we get the filter we want to run and the sort order for that group. In our code, what we're going to do is we're going to reach in here and we're going to add this pre-loop that's going to go out and it's going to create our sequences. So our pre-loop is now going to clear our runtime connection sequence. If the user set use a short to true, so we ask the operator, do you want to use that short? If he says yes, then we're going to add a connection sequence that's going to go in here and put a short in our connection. First run through, we're going to take all of our data points, do all of our 0 points. Then the next run through, we're going to run all of our remaining data points. Okay, so that's how we set this up. And you notice it's in the pre-loop function. So when the run calls, it does nothing under the pre-run. Here with the test setup, it's going to grab, does the technician want to use a short or not? And if he chooses to use a short, then in the pre-loop here, when it makes this call, it's going to call this pre-loop operation, and it's going to configure it with a short or without a short. So next, as we get in here for each one of our loops, we're going to check our connections. If we're running like a multifunction calibrator, we might be telling them put the short on channel 1, put the short on channel 2, put the short on channel 3 if we're doing like an O-scope. That's where they'll get this, is they'll get those connection changes as they're running through their data points. And if they had to connect it to each one of the voltages, they could run either a 9500 doing a 4-channel configuration, because they would have a 4-channel connection message here, or they would run them a single channel at a time. And later I'll build a driver for that so everybody can see how reusable will be able to use 9500s in single channel or multiple channel configurations, and it'll all be using the same basic run function in how it runs those calibrations. So it's going to loop through, grab each connection sequence, grab the filter and the sort order for each connection sequence, give the user the connection, and it'll run the rest of the calibration. Next, we added into this what's going to be the runtime configuration. So as we reach into this test point here, or this test setup, it's going to prompt the operator for whatever has a run configuration as well as the number of data points they want. So the run configuration is now in the reusable class, and it is tagged as overwritable. So if anyone wants to come in and customize how they write their test setup process, they can come in and customize it. Otherwise, it's going to run this code. So it's going to look, does it have a UUT? If it has a UUT, let's get the configuration for the UUT. This is what allows the operator to set the address of the UUT running the calibration. So as it starts up the calibration, they can set the address of the UUT along with the number of runs that they want. This here is using the property info that's .NET reflection. And here with this piece of code here where it says runtime config parameter, it's going to iterate through all the properties of the class. And if the class is a runtime config property, it's going to grab that property and it's going to add that property to the list of what the operator is allowed to set at runtime. Then it's going to ask the user to run his test setup. And this is what brings the user interface up to the user. And they're going to see something like this, where it's going to come in and have the UUT if it's there. They can say use a short, true or false, enter their number of readings, hit enter and continue, and it'll move on with that data. How the metrology.net uses the .NET reflection to auto add this to the user interface so the programmer doesn't have to go through a setup to bring that into the user. It's gonna look at the entire class, grab all of the properties and just push them forward. It's gonna do it by tagging the use short property with this runtime configure parameter, and we set it to editable as true. We gave it a list of it can be true and false, and we gave the user some help information that can be popped up into the UI. And you notice that the use short property is wrappered both with the config parameter, which we covered in previous Lunch and Learns, how the UI uses that for configuring test processes inside of the station agent. This is how the station agent can go through and configure that property. And now we can make any one of these properties a runtime configuration. So as it goes to get it, it grabs the use short, sends true and false out. As a property set into it, it's going to look at it, say if it's true or 1, it's going to set use short to equal true. And that's where it's going to look at that when it's time to build the connection messages. it's going to look at this underscore use short property, determine are we going to give a connection messages with the short and 0 voltages separate, or are we going to put it all together? And this config, runtime config property can be used at any point inside of the code. I think we covered all the objectives here. I know it was kind of like a fire hose receiving all this information, but does anybody have any questions?
Yeah, one thing I noticed was there's a test done to an oscilloscope where you insert a 50 ohm terminal and then just measure the DC offset with no calibrator attached to it. There's is there a test process for oscilloscopes to use the UUT with a 50 ohm terminal as opposed to a UUT with a short, like a meter?
Yeah. Inside there should be a DC and low test process that's going to have that in it. Yeah, so there's a UUT oscilloscope, and then there's test processes. So there's a test process source termination.
Right. I'm guessing in the test package, the test process must be named differently because I never could get it to work.
Yeah, it's got to be named. So if you open up the code and look at this, so underneath the head information, it has to be named like this: test process source termination.
Yeah, with or without the periods? With the periods, correct?
With the periods, yes.
Yeah.
I'm looking forward to writing the driver now.
Yeah. So any other questions, comments?
Thank you, Michael.
Yep, you're welcome.
Thanks, Mike.
Thanks, Mike.